All right, I'm back, page 281 of the notes. I'm pretty excited about this because there's nothing for me to do. It's mostly talking, and I feel like I've been doing a lot of talking, but also a lot of doing, and I'm not disappointed to see that this is mostly a thing for you to do some practice problems on your own. So this says, discuss any and all interesting limits that might be found for each of these functions. So those are typically your discontinuities and your limits at positive and negative infinity. Those are usually the most interesting. Write down in detail any and all information you can figure out. Holes, vertical asymptotes, horizontal asymptotes, jump discontinuities. Yeah, all of those. Also find any zeros of the function, state the y-intercept if it has one. Use any of these wherever they're appropriate. And then it lists a bunch of things. So it's pretty clear. You can do this on your own. You could not do it. You could do it and submit it to like a Google group or somehow so that other people can look at it and share their comments. I think that'd be a great thing to do. A lot of this is on you, and I wish that I could help you out even more than I'm trying to. Mostly I'm making the videos. Both your teachers are there anytime you have questions, so make sure you're reaching out, and we'll do our best to help you. So this page is just a lot of stuff that you should have memorized already. So limit is just a logical y value. If you can say that the limit exists at a point, you're saying the limit from the left and the right both exist and are equal. We have no idea what the value of the function is. That's one of the key takeaways from limits, is that they tell you nothing about the value of a function. Continuity tells you something about it, but not a limit. And then we have left-hand limit, right-hand limit. You know what those are, hopefully, by this point. Continuity, limit exists, function exists, limit equals the value of the function, 3 parts, just make sure you can reel them off. Feel free to do this while you're reeling them off. It's even better if you're pointed at a webcam while you do it. But I've discovered I don't really like the way that my fingers, like by default, kind of do this. It's not my favorite thing. Live long and prosper, I guess, is Star Trek there. All right, so this graph is no joke. It looks like a joke. And I'm going to wrap up the video on this, but I've been doing this longer than I really even care to say at this point, but like almost 20 years. And I have noticed this is definitively true. If you memorize the things that you are told to memorize, you will be successful in the long run. Virtually guaranteed. Got to memorize them. If you don't have them memorized, you can't use them. And everything we do just keeps building on it. So sit down, put in the effort, memorize it, go on Quizlet, make flashcards, whatever. You got to memorize this stuff. If you memorize it, you will be fine. If you don't memorize it, because of the way that everything builds on previous information, you will actually get worse over time. It's not like you can maintain what you're doing without memorizing these things. You're starting off here. If you memorize, you have a chance to go this way. If you don't memorize, you're starting here. This is pretty much the best you will ever be, and it'll just keep getting worse because the next thing we do will depend on this thing. Then after that, it'll depend on those 2 things. Calculus is really different from other things that you've learned where nothing will ever go away. It's kind of like the unit circle, right? If you didn't know the unit circle, I imagine analysis has been very challenging for you. If you know the unit circle, it keeps coming up and you're just like, got it, right? So that's what we want here. So I'm going to end this video here, come back, do more with you. But I think this is a good talk, everybody. Thanks for coming. I'll see you in the next one.